My dear students, welcome back to our channel. In this video, I will be explaining the MCA second semester subject Operations Research as prescribed by Osmania University and other universities of Telangana. We will go through the important questions and answers one by one. Let's begin with a quick revision. Unit 3 first important short question is: what is an assignment problem? Assignment problem. The assignment problem is a special case of the transportation problem where the goal is to assign tasks to resources, like jobs to workers, machines to tasks, teachers to classes, in the best possible way. Each resource can do only one task. Each task must be done by only one resource. The objective is usually to minimize cost or maximize profit. Example: suppose 3 workers, A, B, C, must do 3 jobs, 1, 2, 3. The cost table shows how much each worker charges for each job. By assigning A to job 2, B to job 1, and C to job 3, we may get the lowest total cost. This problem is solved using the Hungarian method, which is simple and systematic. Easy trick to remember. Assignment problem is equal to one person, one job, minimum cost, or maximum profit. Next important short question is: to write the difference between balanced and unbalanced assignment problems. Balanced versus unbalanced assignment problem. 1. Balanced assignment problem. When the number of resources is equal to number of tasks, the problem is called balanced. Every worker gets exactly one job, and every job is assigned. Example: 3 workers and 3 jobs. The assignment table is 3 times 3. 2. Unbalanced assignment problem. When the number of resources is not equal to number of tasks, the problem is called unbalanced. To solve it, we make it balanced by adding dummy rows or columns with zero cost. Example: 4 workers and 3 jobs. Add 1 dummy job with zero cost to make it 4 times 4. Easy trick to remember. Equal rows and columns is equal to balanced. Unequal rows and columns is equal to unbalanced. Make it balanced using dummy. This balancing ensures that the Hungarian method can be applied smoothly. Next important short question is: 3. What is the main idea of the Hungarian method? Hungarian method main idea. The Hungarian method is the most popular technique to solve assignment problems. Its main idea is to find the minimum cost or maximum profit assignment in a step-by-step way without checking all possible combinations. The method works by reducing the cost table systematically. 1. Subtract the smallest value in each row from all row elements. 2. Subtract the smallest value in each column from all column elements. 3. Draw the minimum number of horizontal vertical lines to cover all zeros. 4. If the number of lines is equal to number of rows columns, an optimal assignment is possible. Otherwise, adjust the table and repeat. Example: suppose we have 3 workers and 3 jobs. After reduction, the table shows zeros in places where assignments are cheapest. By assigning jobs to workers at these zeros, we get the least total cost. Easy trick. Hungarian method is equal to make zeros cover zeros, assign at zeros. Next important short question is: 4. Define 0-1 programming model. 0-1 programming model. The 0-1 programming model is a type of integer programming where the decision variables can take only 2 values. 1. Yes, selected. 0. No, not selected. It is used when we have to make yes or no decisions in real-life problems. Example: a company wants to decide which projects to select. Each project either is selected 1 or is not selected, 0. The goal may be to maximize profit or minimize cost, subject to budget or resource limits. Mathematically, let X is equal to 1 if project I is selected, 0 otherwise. Objective, maximize total profit is equal to Px plus Px plus. Subject to cost and resource constraints. Easy trick to remember. 0-1 programming is equal to only two options, take it 1 or leave it 0. It is widely used in assignment problems, project selection, capital budgeting, and scheduling. Next important short question is 5. What is the role of the branch and bound technique in solving problems? Role of branch and bound technique. The branch and bound (B&B) technique is a method used to solve integer programming problems like assignment, knapsack, and scheduling. Its role is to find the best possible solution when variables must take integer values, not fractions. How it works. 1. Branching. The problem is divided into smaller subproblems by fixing variables, example, x is equal to 0 or x is equal to 1. 2. Bounding. For each subproblem, we calculate the best possible solution, upper-lower bound. 3. Elimination. Subproblems that cannot give a better solution are discarded. 4. Optimal solution. The process continues until the best integer solution is found. Example, in a 0-1 project selection problem, if fractional results appear, B&B forces decisions like select project 1 or reject project 0 to reach a correct solution. Easy trick. Branch is equal to divide problem, bound is equal to test limits, result is equal to best integer solution. Next Unit 3. Top 5 long questions. First important long question is: explain the Hungarian method with an example. Hungarian method. The Hungarian method is a step-by-step technique used to solve assignment problems. The aim is to assign tasks to resources, like workers to jobs, in such a way that the total cost is minimum or the total profit is maximum. Steps of the method. 1. Row reduction. Subtract the smallest element in each row from all elements of that row. 2. Column reduction. Subtract the smallest element in each column from all elements of that column. 3. Cover zeros. Draw the minimum number of horizontal and vertical lines to cover all zeros. If the number of lines is equal to order of the matrix n, then an optimal solution exists. If not, adjust the matrix and repeat. 4. Make assignments. Choose zeros in such a way that each row and column gets exactly one assignment. Example. Suppose we have 3 workers, A, B, C, and 3 jobs, 1, 2, 3. The cost matrix is Job 1, Job 2, Job 3. A485, B769, C856. Row reduction. Subtract row minimums. A 0, 4, 1, B 1, 0, 3, C 3, 0, 1. Column reduction. Subtract column minimums. Final matrix has zeros positioned at A1, B2, C3. Assign accordingly. A job 1, cost is equal to 4. B job 2, cost is equal to 6. C job 3, cost is equal to 6. Total minimum cost is equal to 16. Easy to remember. Hungarian method works like: reduce, cover, assign. It avoids trial and error and gives the best assignment directly. Next important long question is: 2. Describe different types of assignment problems with illustrations. Types of assignment problems. An assignment problem is about assigning resources to tasks in the best way. Depending on the situation, there are different types of assignment problems. 1. Balanced assignment problem. Number of resources is equal to number of tasks. Each resource is assigned exactly one task, and each task gets exactly one resource. Solved directly using the Hungarian method. Example. 3 workers A, B, C and 3 jobs 1, 2, 3. Each worker does one job. Job 1 job to job 3. A 485. B 769. C 856. 2. Unbalanced assignment problem. Number of resources is not equal to number of tasks. Make it balanced by adding dummy rows or columns with zero cost. Example. 4 workers, 3 jobs add 1 dummy job. Cost is equal to 0, 4 times 4 table. 3. Maximization assignment problem. Goal is to maximize profit or efficiency instead of minimizing cost. Convert it to a minimization problem by subtracting each element from the largest element in the matrix, then solve using Hungarian method. Example. Assign workers to machines to maximize output. 4. Special assignment problem. Constraints are added, such as certain workers cannot do certain jobs, infeasible assignments. Some jobs must be assigned together. Solve by marking forbidden assignments with a very high cost. Easy trick to remember. Balanced versus unbalanced based on equality of rows and columns. Minimization versus maximization based on objective. Special assignment constraints like forbidden assignments. Illustration tip. Use a matrix table with rows as resources and columns as tasks. Fill costs or profits, then solve. This is simple to visualize and remember for exams. Next important long question is 3. Discuss integer programming and explain the cutting plane algorithm. Integer programming IP. Integer programming is a type of linear programming where some or all decision variables are restricted to take integer values. Used when solutions cannot be fractional. Common in assignment, scheduling, capital budgeting, and project selection problems. Types of IP. 1. Pure integer programming, all variables are integers. 2. Mixed integer programming, some variables are integers, others can be fractions. 3. 0-1 programming, variables take only 0 or 1, yes-no decisions. Cutting plane algorithm. The cutting plane algorithm is a method to solve integer programming problems. It starts by ignoring the integer restrictions, solving the problem as a normal linear programming (ALP) problem. Steps. 1. Solve the AP relaxation, ignore integer restrictions. 2. If all variables are integers, optimal solution found. 3. If some variables are fractional, add a new constraint, cut, that excludes the current fractional solution but keeps all integer solutions feasible. 4. Resolve the AP with the new constraint. 5. Repeat until all variables are integers. Integer optimal solution. Example. Suppose a company wants to produce products X and Y with constraints on resources. Solving ALP gives X is equal to 3.5, Y is equal to 4.7 fractional solution. Using cutting plane method, we add a new constraint to remove this fractional solution, like X less than or equal to 3 or X plus Y less than or equal to 7, and solve again. After iterations, we get an integer solution, example, X is equal to 3, Y is equal to 5, which satisfies all constraints and is optimal. Easy way to remember. Solve ALP first if fractional, cut, resolve, repeat. Cutting planes cut off non-integer solutions while keeping integer ones feasible. Applications. Assignment and scheduling problems. Capital budgeting with limited funds. Production planning where fractions are impossible. Next important long question is 4. Explain the branch and bound technique for solving assignment problems. Branch and bound technique for assignment problems. The branch and bound (B&B) technique is a method used to solve integer programming problems, including assignment problems, where the goal is to find the best assignment, minimum cost or maximum profit. It is especially useful when the Hungarian method cannot be directly applied due to additional constraints or very large problems. Main idea. 1. Branching. Divide the problem into smaller subproblems by assigning a task to a resource. Example, assign worker A to job 1 or not. 2. Bounding. For each subproblem, calculate a lower bound on the total cost, minimum possible cost if the subproblem is completed. 3. Pruning. Elimination. If the lower bound of a subproblem is greater than the current best solution, discard it. 4. Continue, repeat branching and bounding until the optimal integer solution is found. Example. Suppose 3 workers, A, B, C, and 3 jobs, 1, 2, 3, with the following cost table. Job 1, job 2, job 3. A 485. B 769. C 856. Step 1. Start with no assignments. Total cost is equal to 0. Step 2. Branch by assigning A job 1. Calculate lower bound for remaining assignments, B and C. Step 3. Branch A job 2 and A job 3. Calculate lower bounds. Step 4. Prune branches where lower bound current best cost. Step 5. Continue until each worker is assigned exactly one job, selecting the branch with minimum total cost. Optimal assignment. A job 1, 4, B job 2, 6, C job 3, 6. Total minimum cost is equal to 16. Easy way to remember. Branch is equal to divide choices. Bound is equal to calculate minimum possible cost. Prune is equal to eliminate worse solutions. Result is equal to best assignment. Next important long question is 5. Write a note on 01 implicit enumeration algorithm with example. 01 implicit enumeration algorithm. The 01 implicit enumeration algorithm is a method used to solve 01 integer programming problems. In these problems, each decision variable can take only 0, no, or 1, yes. The method is useful for problems like project selection, capital budgeting, or assignment problems where fractional solutions are not allowed. Main idea. 1. List all possible combinations of 0 and 1 for decision variables. 2. Calculate the objective function, total cost or profit, for each combination. 3. Use bounding to eliminate combinations that cannot give a better solution than the current best. 4. Continue until the best combination of zeros and ones is found. This is called implicit enumeration because we do not check every combination explicitly. Instead, we prune impossible or worse solutions early. Example. A company can select from 3 projects, P1, P2, P3. Each project has a profit and requires resources. Project profit resource required. P1 42. P2 31. P3 53. Total available resources is equal to 4. Define decision variables x is equal to 1 if project is selected, 0 otherwise. Objective maximize profit is equal to 40x plus 30x plus 50x. Constraint 2x plus 1x plus 3x less than or equal to 4. Steps 1. Start with all projects unselected. X is equal to x is equal to x is equal to 0. Profit is equal to 0. 2. Try selecting projects while checking resources. X is equal to 1, X is equal to 1, resources is equal to 3, profit is equal to 70. X is equal to 1, X is equal to 1, resources is equal to 5, exceeds limit, prune. X is equal to 1, X is equal to 1, resources is equal to 4, profit is equal to 80, feasible. 3. Optimal selection, X is equal to 1, X is equal to 1, total profit is equal to 80. Easy way to remember. Only 0 or 1 variables. Prune impossible solutions early. Select combination giving best objective.